ground fault interrupter, or GFI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the balance of current between the hot and neutral conductors in an electrical circuit. If the GFI detects an imbalance, indicating that current is leaking to ground, it quickly trips the circuit to cut off the power and prevent a potentially dangerous situation. When the main panel GFI trips intermittently, determining the root cause can be a process of elimination. Firstly, consider equipment with transient loads. Devices that draw a larger amount of current upon startup, such as motors, air conditioners, and compressors, can create a temporary current imbalance that may trip the GFI. This is especially true if the equipment is older or not functioning optimally. Secondly, loose or damaged connections can also cause GFI tripping. Poor connections introduce resistance into the circuit, which can lead to voltage drops and current imbalances. Similarly, damaged wires can create a path for current to leak to ground. Thirdly, a ground fault in the wiring itself can be the culprit. This occurs when a live conductor comes into contact with a grounded surface, such as a metal enclosure or a water pipe. The resulting current flow to ground triggers the GFI. Fourthly, moisture or corrosion can compromise the insulation of electrical components, creating a conductive path to ground and causing the GFI to trip. This is more likely to occur in damp or humid environments. Fifthly, harmonic distortion can also contribute to GFI tripping. Nonlinear loads, such as electronic devices with switched-mode power supplies, generate harmonic currents that can distort the sinusoidal waveform of the alternating current power supply. These harmonics can create imbalances in the circuit and trip the GFI, especially if the GFI is particularly sensitive to harmonic frequencies. Sixthly, external factors can sometimes interfere with the operation of a GFI. Electromagnetic interference from nearby equipment or lightning strikes can induce voltage surges or current spikes that may cause the GFI to trip. To troubleshoot a main panel GFI that is tripping, follow a systematic approach. 1. Test the GFI itself. Use a GFI tester to verify that the GFI is functioning correctly and trips when a ground fault is simulated. This will rule out the possibility of a faulty GFI. 2. Identify the faulty circuit. Turn off all the circuit breakers in the main panel except for the GFI breaker. Then reset the GFI. If it holds without tripping, begin turning on the breakers one by one, waiting a few minutes after each one to see if the GFI trips. The circuit that causes the GFI to trip is the one with the problem. 3. Inspect the circuit. Once you have identified the faulty circuit, carefully inspect all the wiring, connections, and equipment on that circuit. Look for loose connections, damaged wires, signs of moisture or corrosion, and any other potential sources of ground faults. 4. Use an amp clamp. Use an amp clamp meter to measure the current flowing through the hot and neutral conductors of the circuit. If there is a significant difference in current between the two conductors, it indicates that current is leaking to ground. 5. Check for neutral ground faults. A neutral to ground fault can occur when the neutral conductor is inadvertently connected to ground at some point in the circuit. This can cause current to flow through the ground path, tripping the GFI. Use a multimeter to check for voltage between the neutral and ground conductors. There should be little to no voltage present. 6. Examine equipment closely. Pay close attention to any equipment on the circuit that is known to cause transient loads, such as motors or compressors. These devices may require maintenance or replacement if they are causing the GFI to trip. 7. Consider harmonic filtering. If harmonic distortion is suspected to be the cause of the GFI tripping, consider installing harmonic filters to reduce the level of harmonics in the electrical system. This can improve the overall power quality and prevent nuisance tripping of the GFI. 8. Check for shared neutrals. Shared neutral circuits, where multiple circuits share a single neutral conductor, can sometimes cause GFI tripping due to current imbalances. Ensure that all circuits are properly wired with dedicated neutral conductors. 9. Verify proper grounding. Ensure that all equipment and enclosures are properly grounded to provide a low impedance path for fault current to flow back to the source. This will help to ensure that the GFI trips quickly in the event of a ground fault. 10. Monitor the circuit. After making any repairs or modifications, monitor the circuit for a period of time to see if the GFI continues to trip. If the tripping persists, further investigation may be necessary. In a 480 or 277 volt system, the principles of GFI operation remain the same, but there are a few additional considerations. Firstly, insulation requirements. Higher voltage systems require higher levels of insulation to prevent ground faults. Ensure that all wiring and equipment are properly insulated and rated for the voltage level. Secondly, arc flash hazards. Working on high voltage systems can pose a significant arc flash hazard. Always wear appropriate personal protective equipment, or PPE, and follow safe work practices when working on or near energized equipment. Thirdly, transformer considerations. If the 480 or 277 volt system is derived from a transformer, ensure that the transformer is properly grounded and that the grounding system is in compliance with applicable codes and standards. Fourthly, motor control centers, or MCCs. Motor control centers are commonly used in industrial facilities to control and protect motors and other electrical equipment. Ensure that the MCC is properly grounded and that all GFI devices are functioning correctly. Fifthly, lighting systems. Lighting systems that operate at 277 volts can also be a source of ground faults. Inspect lighting fixtures and wiring for signs of damage or deterioration. Sixthly, surge protection. Install surge protection devices, or SPDs, to protect the electrical system from voltage surges caused by lightning or other transient events. SPD can help to prevent GFI tripping and protect sensitive electronic equipment. Seventhly, regular maintenance. Implement a regular maintenance program to inspect and test all electrical equipment and wiring. This will help to identify and address potential problems before they lead to GFI tripping or other electrical hazards. Eighthly, qualified personnel. Ensure that all work on electrical systems is performed by qualified and licensed electricians who have experience working with high voltage systems. If you are unable to identify and fix the cause of the GFI trip, it is recommended to contact a qualified electrician for further diagnosis and repair. Working with electrical systems can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. A qualified electrician will have the knowledge, skills, and experience to safely and effectively troubleshoot and repair electrical problems. Furthermore, they can use specialized equipment, such as insulation resistance testers and power quality analyzers, to identify hard-to-find ground faults and power quality issues. They can also provide guidance on how to prevent future GFI tripping and ensure the safety and reliability of your electrical system. Therefore, when dealing with a main panel GFI that trips randomly, a methodical troubleshooting approach, combined with the expertise of a qualified electrician, is essential for identifying and resolving the underlying cause and ensuring the safety of the electrical system. Remember, safety should always be the priority when working with electricity. Always to energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working with electricity, call a qualified electrician.